In this very video, we are going to be looking at integrating factors for non-exact differential equation. But please, before you continue, just quickly click on the subscribe button below there to get updates of all our classes. Okay. Now, by definition, now there are different cases. But in this very video, we are going to be focusing on case 1. Now, given a non-differential equation, a non-exact differential equation, which is written as mxy dx plus nxy dy equal to 0. Now, the first condition is that if partial derivative of m with respect to y minus partial derivative of n with respect to x equal to a function of x, that's a function of x. Okay, if it is equal to a function of x, then this is the integrating factor. Remember, an integrating factor is just an expression you can multiply your expression with to give you what you want, what you're looking for. Okay, so if partial derivative of m with respect to y minus partial derivative of n with respect to x divided by n gives us a function of x, it means that exponential integral of f of x dx is the integrating factor. Now, secondly, here, also, if the partial derivative of m with respect to y minus the partial derivative of x with respect to n with respect to x all over m, not n, sorry, that is m. Please correct that. Equal to minus gy. Then integrating factor is exponential minus integral of gy dx. That means gy there means a function of y. Okay, so the integrating factor, like we know, will return the equation to an exact when you multiply through by that integrating factor. Now let's see a particular question here. We have to solve this x squared plus y squared plus x dx then plus xy dy equal to 0. Now remember, we call this our m, okay, and we call this our n. Okay, so which it's supposed to look like an exact equation, which is m dx and n dy. Okay, so you can see there that your m is equal to x squared plus y squared plus x. Now, such that if I want to find the partial derivative of m with respect to y, differentiate this with respect to y is 0 because it does not have y. Differentiate this with respect to y is 2y. Differentiate with respect to y is also 0. So it means that is why we got this 2y here. The same thing when you pick n being equal to xy, n being equal to xy, and you want to find the partial derivative of n with respect to x, that is going to give us, we are differentiating with respect to x, so that means we'll just get y. Differentiating x is 1, so 1 times y is y, so that's why we have y. Now if you look at it, this is not exact, because for an equation to be exact, it means that the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x, but they are not equal. So what we do first of all is to find the partial derivative of m, that we subtract it. That means we are supposed to have the m over dy minus the n over dx. Okay, so what we are going to get there is 2y minus y, and which is equal to y. Now, you are going to compare this with your m and your n to see which one will give you either a function of x or a function of y. But we see that when we divide by n, when you divide y all over n, your n is xy. You see that y will cancel y, and that will give you 1 over x, which is a function of x, meaning just x. Okay, so since we have that giving us the function of x, we can now introduce an integrating function, which is exponential integral of that function of x, which is 1 over x. An integral of 1 over x is ln x, and exponential in x is x. Okay, so the next step is to multiply your equation through by that integrating factor, and that is exactly, this is our original equation. Now after multiplying it by x, we got this. You see, x squared becomes x cubed, y squared becomes xy squared, x becomes x squared. Okay, here xy becomes x squared y. Okay, so you notice that if here now becomes our m and here becomes our n, you can see that the partial derivative of m with respect to y gives us 2xy, and the partial derivative of n with respect to x gives us 2xy, which is equal, which is exact. You see, that's the purpose for the integrating factor, to make the equation to become exact. Okay, so now the solution to an exact equation is that we let uy, u is the solution, but the u is such that du over dx plus du over dy equal to m dx plus n dy. That means your du over dx here is your m, and your du over dy here is your n. Okay, so we can start with any. You can start with m, you can start with n, you will arrive at the same answer. But here we choose to start with m, so we say m equal to du dx, which is equal to this, that this is our m now, our new m, and y this is our n, so which is s cubed plus xy squared plus x squared, which when we make u the subject of the formula, we are going to get u equal to this integral of s cubed plus xy squared plus x squared. Okay, so if we integrate, integral of s cubed now will give us x raised to power 4 over 4. That means x 3 plus 1 over 3 plus 1. That gives us x4 all over 4. Okay, that's why we have that. Then integral of x squared y squared. Remember, we are integrating with respect to x, so you just integrate x, which is x squared over 2, x squared y squared over 2. Okay, plus integral of x squared will give us x cubed over 3. Then whenever you are integrating a function of x, y, with respect to x, it means that the constant must be a function of y. Okay, so that's why we have that. So we now have that our u is equal to x4 over 4 plus x squared over squared, x squared y squared over 2 plus s cubed over 3 plus ty, which is a function of y. So we can go ahead now to find du dy. Du dy, that means the partial derivative of u with respect to y, which is n. So when you differentiate this with respect to y, it's going to be 0 because it has no y. Then when you differentiate this with respect to y, it gives us x squared y. Because if you say you are differentiating x squared y squared over 2, okay, the derivative now will be 2x squared y all over 2. Okay, or you can say y raised to power 1, you're differentiating y, so 2 cancels 2 and you're going to get x squared y. That's how we got that. Then when you differentiate a function of y, differentiate s cubed over 3 is 0, because with respect to y, it has no y, so it's 0. Then differentiate ty, you get t prime y. That the prime there shows the derivative of the function ty. Now if we continue from there, you can see now that du dy is this, just like we saw, x squared y plus t prime y. Now, but du dy is also n, if you remember, is also n. Okay, and our n is x squared y. So if we equate that to x squared y, that means to our n, remember, du dy is equal to n, in the same way that du dx is equal to m. Okay, so we equate that. And when we do that, you can see that s squared y will cancel s squared y. That means t prime y is equal to 0. And if t prime y is 0, it means that ty, sorry, not t prime, it means that ty will be integral of 0. And integral of 0 will just give us a constant c. So it means that the solution now to our equation, you have your u equal to x raised to power 4 over 4 plus x raised to power 2y squared over 2 plus s cubed over 3 plus ty. We just replace ty now with our constant c, and that gives us the final answer of this very question. I want to believe that this is clear. Now let's see another example here. Okay, so we have 2xy raised to power 4 exponential y plus 2xy raised to power 3 plus y dx, which the whole of this can represent an m. Then s squared y4 exponential y minus s squared y squared minus 3x, the whole of this can be our n. Okay, equal to 0. Now, according to an exact differential equation, I should find the m dy. That means the partial derivative of m with respect to y. Okay, so if we differentiate this with respect to y, we are going to get this and this. If you differentiate this with respect to y, you're going to get this. Then when you differentiate y with respect to y, you get 1. Now, you may wonder, how do I differentiate 2xy raised to power 4 exponential y with respect to y? Now, we use, what is it called now? Product rule. And our product rule is u v prime, plus u prime v, where we have two functions of y here. So that's why we are applying product rule. The whole of this here can be my u, and y exponential y can be my v, okay? So my u now is 2xy raised to power 4. Then v prime means derivative of exponential y, which is still exponential y. Then plus u prime, differentiate this u with respect to y, is going to give us 8x y cube, okay? Then v is exponential y. That is the reason why, we got this. Now, when you differentiate 2xy cube with respect to y, you get 6xy squared. Then when you differentiate y with respect to y, you get 1, okay? So that is that. Now, for this, for our n here, the same thing here is product rule, You can make the whole of this your u, then make here your v, then apply product rule, which is u v prime plus u prime v, okay? So your u here is x squared y 4, okay? Your v prime means differentiate exponential y, which will still be exponential y, plus your u prime, differentiate x squared y 4 with respect to y, remember? That will be 4x squared y cube, Then your v is constant, which is exponential y. That is exactly... okay, sorry, we are differentiating with respect to x. That's a mistake. Let's do that again. So let's rub this off. So that would not lead us. That is not a product rule, because we are differentiating. We ought to differentiate with respect to x. So differentiating this with respect to x, we are going to get this, 2x y raised to power 4 exponential y. Differentiating this with respect to x, we're going to get this 2xy squared. Differentiating this with respect to x, we're going to get this, which is 3. Okay, sorry for a mistake earlier. Now, if you look at the whole of this, like we said, it is not an exact. These are not equal, so it's not an exact. So the best way is to find a suitable integrating factor that can make it exact. And the way we can do that is by subtracting partial derivative of m over with respect to y minus partial derivative of n with respect to x. And if we do that, if we subtract this minus this, okay, I think this minus this should cancel. Sorry about that. Okay, so this should cancel this, okay? Then this, we have this, which is exactly what we have here, okay? Then 6xy squared, 2xy squared, they look alike. So when you subtract, it's going to be 6 minus minus 2, which will give us 8xy squared. That's how we got this. Then the same thing here, 1 minus minus 3. Let me do that again. This already is the same with this, so they cancel out, okay? So if we have 6xy squared minus then minus 2xy squared, remember? So minus minus there is plus. That will give us 8xy squared, okay? Now, in the same way, if we, as we have 1, we have 1 minus then minus 3. Because we are subtracting, that's going to give us 4. That's exactly, how we got this. And if you notice, there 4 is common. So when we factorize 4, we get this. Okay, so we move to the next page here. We have, this is where we're coming from. We have this. But m, if you notice, this is the value for m. M is equal to this. Okay, this is an observation. When we factorize y, we are going to get this. Now, if you compare this first equation here with this, you discover that the whole of this can cancel the whole of this. And if we divide that just like you see here, we are going to get 4 over y, which is a function of y. And remember that we said that the function of y, the partial derivative of y minus partial with respect to y, partial derivative of m with respect to y, minus partial derivative of n with respect to x, divided by m, should give us a function of y, which is minus gy. Okay, so we can say if minus gy is 4 over y. So that means that gy is going to give us minus 4 over y, something like that, you know. So, and we say that the integrating factor in that case, since the function of y is going to be exponential minus of gy, you know, dy. Okay, so that's why we have exponential minus 4 over y dx. Sorry, that should be dy. Okay, so it should be y now, which means exponential minus 4 ln y, and that's going to give us 1 over 4, because exponential minus 4 ln y is y raised to the power minus 4. Okay, so that gives us 1 over y raised to the power 4, which is our integrating factor. Now, just like we know, we are going to multiply the equation through by our integrating factor to get an exact equation. So if I multiply the whole of this by 1 over y raised to the power 4, I'm going to get this. You know, you can do that quickly. You know, multiplying by y raised to the power minus 1 over 4 is like dividing by y raised to the power. This will give us this. It will cancel y raised to the power 4. Y cubed over y raised to the power 4 will give us y raised to the power minus 1. Y over y raised to the power 4 gives us y raised to the power minus 3. In the same way, if I multiply through by 1 over y raised to the power 4, I'm going to get this, because this will give me this, and this divide y squared by y raised to the power minus y raised to the power 4 will give us y raised to the power minus 2. And the same thing here, this will give us this. Okay, so now the whole of this now becomes my m and my n. Partial derivative of m with respect to y gives me this, and partial derivative of n with respect to s gives me this, which is equal, which is now an exact equation. So the integrating factor has done, you know, its job, its purpose. Okay, so now the solution, now we say let m be du dx. Okay, so which is equal to this. This is the value for m. So making use of the formula means to integrate the whole of this. Okay, and we're integrating with respect to x. So if you integrate 2x exponential y, remember you're integrating with respect to x, so it will be 2x squared over 2, you know, then exponential y. So 2 cancels 2. That's how this gives us this. The same way 2x y raised to the power minus 1 is going to give us this. The same way. Then why this? There is no x, so integral of this means to introduce x. And whenever we integrate with respect to x, there must be a constant, which must be a function of y. Okay, so we got this, u equal to this. Now we differentiate u now with respect to y, and if we do that, this will give us this, because derivative of exponential y is exponential y. But this will give us this, because y raised to the power minus 1, the minus 1 comes down, then it becomes y raised to the power minus 2. Then this gives us this, minus 3 comes down, then you have minus 3x y raised to the power minus 4, according to the rule of derivative. Then differentiate this, gives us t prime y. Okay, so which is equal to this. The whole of this, remember, this is our value for n. Remember that du dy is also n. Okay, so if we do that, you see that now let me do this. So you see that this cancels this because they are the same. You see that this on this side cancels this because they are the same. You see that this on this side cancels this because they are the same, and you're left with t prime y to be equal to 0. And when t prime y equal to 0, it means that ty integral of 0 is going to give us a constant. That should be c, a constant c. Okay, so now we can conclude that, remember we said our u is equal to x squared exponential y plus s squared y raised to the power minus 1 plus x y raised to the power minus 3 plus ty. So when we substitute the value for ty plus for c, we are going to get this. So that gives us the final answer of our solution of our question. Thank you very much. Please, if you are yet to subscribe, do well to subscribe so that you can get, you know, more notifications of our classes. Thank you.